Right now, 390 million miles from Earth, there's an ocean that contains twice as much water as all of our planet's oceans combined. It's been stable for over 4 billion years, it has organic chemistry, and NASA just detected water vapor shooting from its surface into space. But this ocean isn't on a planet. It's hidden beneath the frozen surface of Jupiter's moon Europa, and it might be teeming with life. Most of us grew up thinking that life requires a planet like Earth, the right distance from a star, liquid water on the surface, a protective atmosphere. But Europa shows us that life might be hiding in places we never thought to look. Imagine an ocean that's been brewing the chemistry of life for billions of years, protected from the harsh radiation of space by a shell of ice. An ocean kept liquid not by the warmth of a nearby star, but by the gravitational dance between a moon and its giant planet. An ocean that might contain more habitable space than our entire world. For centuries, astronomers assumed that moons were simple, inactive objects, cosmic debris left over from planet formation. If you wanted to find life, you looked at planets in the habitable zone, around stars. But getting this assumption wrong meant we were missing entire categories of worlds that could harbour life. Worlds that might be more common than Earth-like planets. Worlds like Europa. The breakthrough came when Galileo detected something unexpected, changes in Jupiter's magnetic field as it passed near Europa. These changes suggested that Europa contains a conducting fluid, most likely a salty ocean, that interacts with Jupiter's powerful magnetic field. But the real proof was written on Europa's surface. The moon is covered in long, curved lines called lineae, cracks and ridges that crisscross the entire surface like a giant spider web. Think of Europa like a stress ball that's being constantly squeezed. As Europa orbits Jupiter in an elliptical path, Jupiter's gravity stretches and compresses the moon. When Europa is closer to Jupiter, the gravitational pull is stronger. When it's farther away, the pull is weaker. This constant flexing creates friction inside Europa, generating heat, enough heat to keep a vast ocean liquid beneath the ice, even though Europa receives 25 times less sunlight than Earth. The lineae on Europa's surface are the scars of this process, cracks that form as the ice shell flexes and breaks, then refreezes in new patterns. Now, you might be wondering, how big is this ocean? The answer will blow your mind. Europa's ocean is estimated to be 60 to 150 kilometers deep. To put that in perspective, Earth's deepest ocean trench, the Mariana Trench, is only 11 kilometers deep. If you could drain all of Earth's oceans and pour them into Europa's ocean, you'd only fill it halfway. And here's the incredible part. This ocean has been stable for billions of years. While Earth's surface has been reshaped by asteroid impacts, ice ages, and continental drift, Europa's ocean has remained a constant, protected environment where life could potentially evolve and thrive. So Europa has a massive, stable ocean, more water than our entire planet. But water alone doesn't guarantee life. For that, you need the right chemistry. And as we're about to see, Europa's ocean might have the perfect recipe for life. In 2023, Hubble detected carbon dioxide concentrations on Europa's surface that are 10 times higher than scientists expected. But here's the crazy part. Jupiter's radiation is so intense it would kill you in under 10 minutes. Yet this same deadly radiation is creating oxygen in Europa's ice. Every second, Jupiter is splitting billions of water molecules on Europa's surface, creating the exact chemistry that life needs. Scientists calculated that Europa's ocean might contain more dissolved oxygen than Earth's oceans had when complex life first evolved. We're talking about an alien ocean that might be more oxygen-rich than early Earth. Now you might be thinking, okay, so Europa has water and some chemistry, but where's the energy? That's where Europa gets really exciting. On Earth, most life ultimately depends on energy from the sun. But Europa shows us there's another way. Computer models published in 2024 suggest that Europa's ocean floor might have hydrothermal vents, underwater volcanoes powered by the same tidal heating that keeps the ocean liquid. And just like Earth's deep-sea hydrothermal vents, where life thrives in complete darkness using chemical energy instead of sunlight, Europa's ocean floor could be teeming with organisms that have never seen a star. But here's the incredible part. We might not need to drill through kilometers of ice to study this alien ocean. Europa is about to do something that changes everything. For years, scientists faced a seemingly impossible challenge. How do you study an ocean that's hidden beneath 15 to 25 kilometers of ice? Landing on Europa would be incredibly difficult due to Jupiter's intense radiation. Drilling through the ice would require technology we don't have. It seemed like Europa's secrets would remain locked away forever. But sometimes the universe gives us a gift. In 2024, NASA's Juno spacecraft detected something extraordinary during a flyby of Europa. Water vapor in the moon's thin atmosphere. This wasn't just any water vapour, it was evidence of massive plumes erupting from Europa's surface, shooting material from the hidden ocean directly into space. These aren't the first plumes detected at Europa. The Hubble Space Telescope has observed possible water vapour plumes several times since 2012, but Juno's detection confirms what scientists hoped. Europa's ocean is accessible. The result is spectacular: geysers of water vapour and ice particles shooting up to 200 kilometers above Europa's surface. These plumes could contain everything we need to determine if Europa harbors life: organic molecules, dissolved minerals, maybe even microorganisms themselves. The missions heading to Europa right now aren't just scientific expeditions. Europa Clipper mission cost $4.2 billion. That's more than the GDP of some countries. All to answer one question: is there life in Europa's ocean? The European Space Agency's JUICE mission, which launched in 2023, will also study Europa as part of its investigation of Jupiter's icy moons. Together, these missions will give us the most complete picture of Europa we've ever had. We might see a Europa lander within the next 15 years, but if we do find life in Europa's ocean, what might it actually look like? In 2024, scientists discovered bacteria living inside rocks 2 miles beneath Earth's surface. These organisms haven't seen sunlight for millions of years, yet they're thriving. But here's what's terrifying and amazing. Some of these deep Earth bacteria are identical to organisms we find near hydrothermal vents, the same life forms, separated by miles of solid rock, somehow existing in both places. If this can happen on Earth, imagine what's possible in Europa's ocean that's been stable for 4 billion years. We might not just find life, we might find an entire alien biosphere that's been evolving longer than complex life has existed on Earth. In Europa's ocean, life would need to survive in complete darkness, high pressure and cold temperatures. But Earth's deep ocean shows us that this is possible. Near hydrothermal vents on Earth's ocean floor, entire ecosystems exist without any energy from the sun. Bacteria convert chemicals from the vents into energy, and other organisms feed on these bacteria. Similar ecosystems could exist on Europa's ocean floor. Computer models suggest that hydrothermal activity could provide enough chemical energy to support substantial biomass. But Europa's life might be very different from Earth's. The ocean's chemistry, pressure and temperature are all different from Earth's oceans. Evolution might have taken completely different paths. Some scientists speculate that Europa's life might be more similar to Earth's earliest organisms, simple cells that use chemical energy rather than sunlight. Others suggest that the stable conditions in Europa's ocean might have allowed for more complex evolution than we might expect. Jupiter has 4 large moons, and at least 3 of them, Europa, Ganymede and Callisto, likely have subsurface oceans. Saturn's moon, Enceladus, definitely has a subsurface ocean, and Titan might have one too. That's potentially 5 ocean worlds in our outer solar system alone. If life can exist in these environments, the universe might be teeming with life in places we're only beginning to explore. Here's what's going to happen in the next 5 years. Europa Clipper will arrive at Jupiter in 2030. Within 6 months, we'll know if Europa's ocean is habitable. Within 2 years, we'll know if it contains organic compounds. And within 5 years, we might have our answer about alien life. Think about that. You might live to see the day when humanity discovers we're not alone in the universe, and it won't come from a distant star system. It'll come from a moon you can see with binoculars on a clear night. Europa isn't just a moon. It's humanity's first real chance to answer the ultimate question: are we alone?